Sample exam 8, problem number 19. A sequence of independent Bernoulli trials with probability of success P is performed. Let X be the number of trials until the first success occurs. 4 independent realizations of X are X1 equal to 1, X2 equal to 1, X3 equal to 2, X4 equal to 1. If a priori P is a uniformly distributed on 0, 1, and squared error loss is used, what is the Bayesian estimate for P? i.e., what is the expected value of P given the data 1 through 4? Sample exam 8, question 19. It says to find the expected value of P given our data. And before that it says, under squared loss, find the Bayesian estimate. And so even though it tells us what to find, I'm going to derive it. So here we have squared loss, and this is our variable. We want to find the C that minimizes this expectation. Okay, so by definition, this is equal to this. It's whatever is in here times the density. So now to minimize this, we want to take the partial or the derivative with respect to C. So then it goes into the function, and then you take the 2 out front, and then subtract 1, and then take the derivative of the inside, which is minus 1. And then everything else is a constant with respect to C. So we set it equal to 0. And then this constant we can divide to the other side, get rid of it. And then we multiply this in, and that's what this is. But when we integrate our density, that's just 1. So we get C. So if we take C to the other side, we get C is this integral. Well, that's just the expected value of P. So the mean under squared error loss is the mean. So here in the problem, it's given that the prior distribution was uniform 0, 1. So this is the density. It's also given that that the data is negative binomial, or this. And now since there were 4 observations, this is our joint density, which is this, which simplifies to this because the sum of our data is 5. So we get this, and this is actually it's looking like a beta distribution. But now we find the marginal of our data, so we integrate out P from this times that, right? Because if you think about this joint, A given B over here is A intersect B divided by B. But if we multiply this piece up here, then it's the joint distribution of X and P. But if we integrate out P, then it's only left for the X's. So that's a 1. This we found out was this. And remember, this is a 1, so 2 minus 1 is still 1, and 4, so 5 minus 1 is a 4. And I do this because then that is a beta distribution. And with the appropriate constant, it integrates to 1. So if you take the reciprocal of that appropriate constant, that's what it integrates to, which is this, okay? And the gamma functions are just, you take the inside, minus 1, and it's the factorial. So this is 1/30. Well, ultimately we want to find this distribution because we want the mean of this distribution. So A given B is A intersect B over B. Well, the joint can be rewritten as this product. And we're doing that because we know this, and we know this distribution, and we just discovered this one. And so it equals this. that should be a times, because this right here, when this is this, so you invert and multiply and you get this, and then this density is this, which we just found up there. So that should be a times. So now the expected value of this is you just put in P and then times the density. And what we do is since there's an extra P, which will go here, into here, what we do is for this density, we take it times a well-chosen 1. So 6 and 6 and 8 and 8. Otherwise, the whole thing is just this with that extra P. But this, we tricked it to, it looks like a beta distribution, which integrates to 1. So the only thing left is this, and then the answer is 5/7. Number 20, let x1, x2, x3, x4 be a random sample from the discrete distribution given there. If the data are 17, 10, 32, and 5, what is the maximum likelihood estimator of theta? Number 20, it's find the maximum likelihood estimate, and this is our joint density. Take the log of it, and then subtract that off. Take the derivative of this, so that's 1/theta times this constant. That's just 2 theta. That's 0 because it's a constant. Set it to 0. Multiplied through by theta, and we get and I took out a 2, so, and then divided the other side, so we get sum of the xi minus 4 theta squared. Solving for theta, we get 4. Number 21, a drawer contains 6 blue socks and 4 white socks. 2 of the socks are chosen at random and without replacement. What is the probability that the 2 socks are the same color? Number 21, what's the probability that the 2 socks are the same? Well, here, of the 6, there's 2 possibilities. Of the 6 blue socks, we could choose 2 and 0 from the white socks, or, meaning plus, we could choose 0 from the blue and 2 from the white. And this is over the 10, choose 2 possibilities. Oh, yeah. And that simplifies to 7/15. Number 22, let xy be distributed uniformly on the circular disk centered at 0 with radius, and I changed this to 2/√pi. What is the marginal density function of x between this range? And again, that range has been changed to this. Now number 22, remember I changed the radius on this, and the reason I did is because it's the only way to get one of the answers. And so it's a uniform distribution over this disk. And so let's find the area of this disk, which is pi r squared, which then is this, which is 4. So the density has to be 1/4, because the area has to equal 1. And now, this is the formula for a circle centered at 0. So 0, 0, and that's the radius. So if we solve for y, we take the x squared over plus or minus square root, and what that does is it gives us that function, that's the plus, and then the minus is that function. So if we want to find the marginal of x, we have to integrate out y. And it goes from this function to that function. So we're integrating this to that over our joint density, which is 1/4. And then the antiderivative of that is just y over 4. We plug in these values and we get essentially two of those, because the minus and minus is a plus, and then one of those twos cancels and we're left with this. Number 23, let x have the density function f of x given there. The hypothesis, the null hypothesis, theta is equal to 1, is to be rejected in favor of the alternative hypothesis that theta is equal to 2 if x is greater than 0.9. What is the probability of a type 1 error? Number 23, probability of a type 1 error. Now that's under the, assuming the null hypothesis is true, so you plug in theta equal to 1, and we get this as our density under the null, and we reject being greater than 0.9, so that we're going to integrate from 0.9 to 1, antiderivative, plug in our limits, and the answer is 0.19. Number 24. A certain game involves rolling a pair of dice and watching for sevens to occur. What is the probability it takes exactly 10 rolls to observe 8 sevens? So number 24, here we want to find, the probability that it takes 10 rolls to observe 8 sevens. Okay, so if we let A be the event, roll a 7, and then the probability of A is 6 out of 36, which is 1/6. So the probability of not rolling a 7, which is this, is 5/6. Okay, so here's a picture of the scenario. Each little box represents the outcome of a roll. Okay, and it said that we're going to get 8 sevens on 10 rolls. So on the 10th roll, we know it's a 7. But the first 9 rolls, that means we would need 7 out of the 9 to be sevens. Okay, so the probability that x is 10 is this probability is this. 9 choose 7. That's how many different ways you could mix these up, and have 7 sevens. And the probability of a rolling a 7 is 1/6. We want 7 of them. Probability of not is 2. And then this represents the probability on the 10th roll. And then you simplify that and you get 5 squared over 6/8. Number 25. Let y1 through yn be a random variable such that the expected value of I is equal to 2 plus beta xi, I equal 1 to n. Given the observations x1, y1 through xn, yn, what is the least squares estimate of beta? Number 25. We want to find the least squares estimate of beta. And so this is our sum of squared errors. You take the partial of it. Don't forget the chain rule here. Set it to 0. We can get rid of this 2, and then we multiply this in. So here we get this, and then when we multiply that xi in, bring the sum in, we get this, we get that. Set it to 0. Take those to the other side, divide by this, and this is our least squares estimate of beta. Number 26, let the distribution function of x, for x greater than 0, be capital F of x equal to that function. What is the density function of x for x greater than 0? Number 26, we're given the CDF and we want to find the density. So we take the first derivative of the CDF, and that's our density. So it's the derivative of this. Well, this is a constant, so it goes away, and the negative can come out front, and then the derivative passes through the sum, and then this, since there's an x, we have to do the multiplication rule, so it's the derivative of the first times the second, and then plus the first times the derivative of the second, but then that negative makes that negative, and that's a constant, so it just comes through. Well, now this negative can be taken in to make that a positive and this a negative, and then you just plug in k equal to 0 to each of those, k equal 1, k equal 2, k equal 3, and then 0 times anything goes away. That cancels with this cancels with that, this one, yep, cancels with that, because the 3 cancels, makes that 2 factorial, and the only thing we're left with is this. Number 27, let x and y have the joint density function f of x, y equal to x plus y, x between 0 and 1, y between 0 and 1. What is the conditional mean of y given that x is 1/3? So number 27 is find the expectation of y given 3. So first of all, we find the marginal of x, so we have to integrate out y, and then the antiderivative of this, plug in at the limits, we get x plus 1/2. So now we have the density function for y given x. So that's what, not this y, but everything else, it's x plus y over x plus 1/2. But we're plugging in 1/3 to x, so we can plug it in, and then that becomes a constant which factors out, and then we multiply the y in and we get this, and then the antiderivative, plug in limits, the 0 makes it go away, and we get 3/5. Okay, well, that's all I have for today. Hope you enjoyed it. If you did, please like it, subscribe so you don't miss the next one. Thanks. Bye.